you have some microscope, right? You have microscope for about the inspection of metal specimen. I mean optical microscope. So you have optical microscope, you can do some inspection to measure your surface situation. So I think even we use very easy equipment or machine you can do something here. You really want to do something interesting about the microchip. Yeah. So if in the future the faculty want to do this kind of machine, yeah, I can provide all kinds of information, detailed information. Yeah. Today I only give you some briefing, only briefing introduction. Okay. So about the micromachining, we have another way to do it, the surface micromachining. Surface micromachining is the entry barrier is high. You need more machine, more facility to realize it. But the surface micromachining is more precise, So we have mentioned this kind of concept of sacrificial layer for several times, right? So I basically don't understand. Sacrificial layer, structure layer, and finally strip out, remove the sacrificial layer, and the structure layer stay over there. So you have freestanding structure, vibrate all the way. But here, two principles. You need to be aware of. Number one, the deposition of the structure layer cannot destroy the sacrificial layer. Of course, it's true, right? But you need to carry it out. You cannot just it's true, but you arbitrarily select material, arbitrarily select your processing temperature. Very easy to fail, to let your structure fail. You mean what? The deposition of this structure layer cannot destroy the superficial layer. For example, I give you one example. We can do the photolithography, right? Photolithography can coat in photoresist and do some pattern, right, on our silicon wafer. Can we assign superficial layer using photoresist? Can we? Why not? You can say why not? Okay, I assign photoresist pattern as our superficial layer. Okay. But the next step is, what is the structure layer you can have? Many times the structure layer, you want to coat it there. But how about the processing temperature? Coating temperature, pretty high, right? High temperature. A lot of metal or oxide, nitrile, polysilicon, or many kinds of material. When you do the coating, high temperature, the high temperature will kill. Maybe you will kill the superficial layer. If you kill, you will make the superficial layer fully bubble, cake, fluid, everywhere. Can you expect your structural layer can be coated very smoothly? Of course not. Your base is bad. It's very similar to you build up a house. If your base very bad, you cannot expect I want to have the 15th floor. It will be impossible, right? Even one layer, let me crash. So this easy to understand, but not easy to get your mission complete. So you need to knowing about what is the material and the processing temperature. Number one. Number two, when you remove the superficial layer, right, at the step C, you remove that. You cannot destroy the structure layer. Once again, when you remove this superficial layer, you cannot remove the structure layer at the same time. Reasonable, right? So these two terms are different, right? Different. But these two rules are very basic and important. You must satisfy these two conditions. Then your freestanding structure will be successful. Otherwise, impossible. Okay, you say, okay, very easy. I just try to remove that. That's all. But for the etching, we have the etching selectivity problem. It means that this action will achieve the superficial layer. It may be also attached, structure layer. So you must select a proper action solution, only targeting on the surface superficial layer, but not attacking on the structure layer. So the high selective action solution you should find. So it's an action selectivity problem. You must solve these two problems, right? Processing temperature problem and the action selectivity problem. Satisfy both, then your freestanding structure will be survivable there. So it seems very easy, but actually not so. So it's a surface micro machine. Many match. Many methodology. So I show six kind of material and process for surface micro machine. Before 2000, many people only know the first two. We call them polymers. This poly means polysilicon. Remember the micromotor. The first one, micromotor rotate in 1989. Micromotor, they use polysilicon based technology to do the polysilicon and to do. So they assign their structure in the polysilicon. You mean the silicon. Polysilicon is the silicon, but it's a polycrystalline situation, not a single crystal. Because the polysilicon grows on the oxide layer. Oxide is not crystal. So of course, the seam above it is not crystal. It's a polycrystalline. Polysilicon. So the structure is polysilicon. Superficial layer is glass. This kind of glass we call it a PSG. It's a phosphorus silicate glass. It means that in the glass we have dopant with phosphorus, N-type doping inside. Okay, why we select these two kinds of material as our superficial and structure? Okay, we check our previous two rules. These are two rules we need to check. Number one, when we deposit our structure layer, we cannot destroy the superficial layer, correct? When we deposit our polysilicon, we cannot destroy PSG. Impossible? Of course possible. We use LPCVD to do the coating. Polysilicon temperature about 600, it's still fine. To glass. Glass can endure temperature to 1000, no problem. And the growth of the polysilicon only 600 degrees C, so safe for glass. So coating on superficial layer PSG at the first, and then polysilicon at the second, no problem. So first condition satisfied. Second condition, when we finally want to remove the superficial layer, we attack structure layer. It depends on what the agent solution we use. We use what? HF. Hydrofluoric acid. Hydrofluoric acid can remove glass, no problem. But we attack polysilicon? No. Hydrofluoric oxide, HF, will not attack polysilicon very much. Especially, maybe we don't use the HF, we use the very light HF, we call the BOE, buffer oxide H. It's a low concentration HF, safe to our polysilicon. Right? So finally, your structure material, the polysilicon, stay over there. Micromotor, or even a micro tweezer, or many kinds of micro components can be done by this kind of polysilicon based process. So it's a very important process in the milestone for the surface micromachining before 2000. But if you want to do this kind of machine, what's the machine necessary? LPCVD, low pressure chemical vapor deposition, LPCVD. It's all machine. But you know how cost it should be? About 3 krone. About 3 krone. You cannot say India cannot afford. I can tell you, even for Taiwan cannot afford. Our university cannot afford. So before 2000, regarding the surface micromachining technology, we know that. But we just said, just keep it possible to finish. No pressure to do that. You want to do that, go to the United States. You go to Berkeley, Caltech, UCLA, they have this kind of machine. They do that for you. Right? But you just spend money. Maybe for one person go there for half year internship, pay for $30,000 US. You can go into for internship. Very expensive, right? 30,000 US. But anyway, so you can see before 2000, all this material, all this machine, method, impossible. Only possible in United States, Japan, Germany, yeah, only several places, very less. But you know, after 2000, people start to consider about we use other kind of process machine and other kind of easy material to do that. Because if we know these two rules, why we always select polysilicon as our structure, PSC as our silicon, why not change others? Right? Why not change others? So we start to think about others. You know, in Taiwan, we have a very good CMOS IC foundry. CMOS IC, we will talk about maybe tomorrow, I hope. CMOS IC. CMOS IC, we can select aluminum as our superficial layer. Nitride particle polyimide is our structure. It means that we have many kinds of material to select. So number three or number 4 is for our IC, our Taiwan IC factory. They can do that. They can do that. And we only do the design in university and ask them to do the boundaries for us. So we don't need to run the factory. We even more. We only spend little time, but they turn back. We use our etching solution, acid or plasma. We try to remove the superficial layer, and then we have our freestanding structure. So gradually, after 2000, in Taiwan, several devices have been announced using the CMOS advanced technology. It also belongs to the category surface micromachining. Not only that, for us, we start to think about why not use polymer methods. What's the polymer method? This time maybe we have very less time to talk about. Polymer means plastics. Plastics is very easy material, right? Plastic. So we think about how to use the plastic or polymer or even protein. Yes. Plastic, we use a kind of plastic called a paradigm. And this is a gelatin. What is gelatin? You understand the gelatin? It's a melon candy, right? Gummy bear. Yeah, sugar. You know the capsule? Capsule, right? The shell of the capsule. I'll let you calculate the capsule. Capsule is the material, gelatin. And some cosmetics, some grease for makeup, also the gelatin. The gelatin is the natural stuff, protein. So in my research, we start to use different things in our structure layer. So we try to broaden our mindset, not only confined to the conventional material. So for my laboratory, we use a paradigm and the structure. Photoresist at the superficial layer. So very easy, you can do the photoresist. Photolithography, you do the superficial layer. Coating paradigm, then remove the photoresist by alcohol. Easy, right? You can freeze parallel structure. Very easy. Second, if you use the gelatin, similar. We know how to process the gelatin and the kind of photoresist. You can try to cook it now. To do the cooking about gelatin. You can buy the gelatin powder from the market. Gelatin powder in the powder. And then you can do the cooking. 40 to 50 degrees C cooking. And into a gel-like liquid. And we try to process, do the process, spin coating, like the photoresist. We can do the gelatin thing. And the structure. Photoresist, similar as the circulation layer. And finally, use the acetone to remove the photoresist. But acetone will not attack parallel of gelatin. So this kind of polymer preserve. So we have the polymer freestanding structure or gelatin freestanding structure. So this is one of my research in the past 10 years. We have able to do this. We have able to do this and publish some paper, interesting paper. But if you know the spirit of the surface micromachining, you can try to think about new way. Even our facility is bad, but our mindset is big. We can think more match about the material, about making our device. So if possible, I would try some our research result to you, or CMOS man. So it's a local technology in Taiwan. It is my technology in my Hong Kong University. So very easy, very cheap material. Can do something interesting. So don't limit our thinking, our mindset. Okay, so I must stop here. Maybe tomorrow we'll continue talking about the surface thinking problem. We have some problems for the solve. Not only the segmentation layer, structure layer, recipe, not only that. We still have some structural problems. We will talk about